Welcome back to our channel. In this video, we are going to cover implicit differentiation. So sometimes functions are not given explicitly, like y equal to f of x, but implicitly, for example, x squared plus y squared equal to 25. Here, y is not isolated. So implicit differentiation allows us to find dy on the x without having to solve for y explicitly. So in order to apply this method carefully, we're able to outline 4 different steps in order to follow. What is our first step? Start with an equation involving x and y. So in order to apply implicit differentiation, we first need an equation which involves x and y, where y cannot be, or it is difficult to solve for y explicitly. So here's y, not 4. Second step, differentiate both sides with respect to x. Remember that y is a function of x, that is y is y of x. The next step is apply chain rule when differentiating terms in y. Here is a formula which has already been outlined in order to apply the chain rule in differentiating terms in terms of functions in terms of y. And this formula states that the derivative with respect to x of any function f in terms of y is the same thing as the derivative of y with respect to x, that is dy on the x, times the derivative of that function f which is in terms of y with respect to y, that is d of f of y dy. So first of all, I'm going to highlight some keynotes we always need to remember when working throughout implicit differentiation. What is the first keynote? Always differentiate every term with respect to x. In implicit differentiation, every term, that is both terms on the left hand side and the right hand side, are differentiated with respect to x. The next rule is remember chain rule for any term in y. That is, for every function in terms of y, we use the chain rule, which is well stated here, in order to carry out its differentiation. The third step is simplify after differentiation. That is, after every differentiation, after we've differentiated implicitly both sides, we simplify in order to solve for our dy on the x algebraically. So in order to understand, or in order to better understand this concept, we are going to use some examples. So let's start with our first example. We'll call it example 1. What does this example 1 tells us to do? Find dy on the x if x squared plus y squared equals 25. So let's recall back our method in order to perform implicit differentiation. Our first step was to start with an equation in terms of x and y. In this case, we already have an equation in terms of x and y. Next step, differentiate both sides with respect to x. So let's work on that. Derivative with respect to x of our left hand side is equal to the derivative with respect to x of our right hand side. This gives us the derivative with respect to x of x squared plus the derivative with respect to x of y squared equal to the derivative with respect to x of 25. So let's start with our first term. What is the derivative with respect to x of x squared? The derivative with respect to x of x squared gives us 2x to the power 2 minus 1, which gives us 2x. Our next term, what is the derivative with respect to x of y squared? If we can still recall from our formula, it stated that the derivative with respect to x of any function in terms of x is the same thing as dy on the x times the derivative of that function with respect to y. So this gives us dy on the x times the derivative of this function with respect to y. Now, the derivative of this function with respect to y gives us the term 2y into 2 minus 1, which gives us dy on the x times 2y. Now move on to our last term. The derivative with respect to x of our constant 25 is equal to 0. This is all from our constant rule, which states that the derivative of any constant with respect to x, or the derivative in general of any constant, gives us 0. So all we need then to do is to substitute these terms in our initial expression here, which is this. We substitute this and this in this expression. This leaves us with d on the x of x squared, 2x, d on the x of y squared dy on the x times 2y is equal to 0. So let's move on to our third step. Our next step, which is solve for dy on the x algebraically. In order to solve for dy on the x algebraically, the first thing we need to do is make the term or the function dy on the x the subject of the formula. This leaves us with dy on the x times 2y equal to negative 2x, which implies that dy on the x we divide all through by 2y in order to make dy on the x the subject of the formula on 2x, which is equal to negative x on y. So we can then conclude that the derivative of y with respect to x is equal to the function negative x plus y. We enclose our answers. So in order to still emphasize this notion, let's move on to the second example question, right? Or practice question 1. Practice question 1. So what does this practice question 1 ask us to do? Find dy on the x if x squared plus sine y is equal to 0. So we'll still follow the same steps. What's our first step? If you can still recall, our first step was to ensure that we have an equation in terms of x and y. In this case, we already have. What was then our next step? Our next step was to perform differentiation with respect to x on both sides. So let's apply that. This implies that the derivative with respect to x was our left hand side, x squared plus sine h is equal to the derivative with respect to x of the right hand side. And what is the right hand side? Sorry, here is 1, not 0. Yes, I wanted to put 1 there. Derivative of 1, there wouldn't have been a point with 0. I just want to change it to 1, which gives us, so that is it. The next thing we do is separate our left hand side, that is d on the x of x squared plus d on the x of sine u plus d on the x of 1 sine y. Sorry. So let's start. What does this first term gives us? 2x plus, what does the second term gives us? dy on the x times the derivative with respect to sine y on sine y on, sorry, with respect to x, what am I writing? With respect to y on dy. So this is dy on the x times d of sine y on dy is equal to, what's the derivative of a constant? Derivative of a constant gives us 0 from constant 1. This leaves us with 2x plus dy on the x. In bracket, what's the derivative of sine y with respect to y? We have cos y. Cos y, right? The derivative of sine y with respect to y is cos y equal to 0. Now what does our next step ask us to do? Our next step asks us to simplify and make or solve for dy on the x algebraically. Solving for this algebraically just tells us to make dy on the x the subject of the formula. So let's go ahead and make it. We have dy on the x times cos y equal to negative 2x, implies that dy on the x is equal to negative 2x divided by cos y. So in conclusion, derivative of y with respect to the x with respect to x is a function negative 2x on cos y. So let's move on to our third question or practice question 2. And what does this question ask us to do? Find dy on the x if x cubed minus y cubed minus 3xy is equal to 1. So what's the first thing we do again? First thing is we ensure we have an equation in terms of x and y, which we already have. Our second thing to do is apply differentiation on both sides. So let's apply it. D with respect to x of our left hand side, which is x cubed minus y cubed minus 3xy, is equal to d with respect to x on our right hand side, which is 0. We can then simplify the left hand side down to minus x cubed minus derivative with respect to x of y cubed minus derivative with respect to x of 3xy equal to derivative with respect to x of 0. So what's the derivative of x cubed? It gives us 3x squared minus derivative of y cubed, which is dy on dx, and the derivative of y cubed with respect to y minus derivative of 3xy, we have 3 outside, times the derivative with respect to x of xy equal to derivative with respect to x of 0 is 0. So let's start with that. The derivative of y squared equal to so here's y equal to 3y cubed minus z squared. Moving on to our next term, the derivative with respect to x of xy. We notice that this can be considered as two products, right? With our first term being x and our second term being y. So the derivative of two products, what we need to use here is the product rule. And what does the product rule state? It says that the derivative of two products f and y is same thing as f g prime plus g f prime. So this gives us x times d of y on the x plus y times d of x on the x. This leaves us with x dy on the x plus 1. Yes, plus y times, yes, this is it already. Plus y times, what is the x on the x? The x on the x is 1, right? The differential of x with respect to x is 1. So this leaves us with y plus x dy on the x. So all what we need to then do here is substitute. All we need to do is substitute the different values, that is d of y cubed, d of xy, into our initial equation. So this implies that 3x squared minus dy on the x times what's dy cubed on dy. This is it here, times 3y squared minus 3, what is d of d on the x of xy, it is this y plus x dy on the x equal to 0. So let's simplify this. We have 3x squared minus 3y squared dy on the x minus 3y minus 3x dy on the x equal to 0. So our next step then is to make dy the complex of the formula. How can this be? Times on the x leaving us with 3x squared minus 3y. What if this becomes positive? 3y squared dy on the x. The other term becomes positive plus 3x dy on the x. Now we factorize out dy on the x, right? We have dy on the x into 3y squared plus 3x equal to 3y. Yes, yes, minus 3y. Hope it's moving. We can then find the y on the x later by dividing all through by this term, leaving us with 3x squared minus 3y on 3y squared minus 3 on 3y squared minus 3x. Make that 3 is common, so we can factorize out 3, right? Leaving us with 1, 3 is everywhere, x squared minus y on y squared minus x. So what can we then conclude? Our conclusion is the derivative with respect to y on x is equal to x squared minus y on y squared minus x. We box answer. So in the going to solve much more questions using implicit differentiation in order to ensure that the concept is much and perfectly understood. Thank you for watching the video.